Okay. Oh, very loud. Give me a second. Better? Yeah, I guess. Okay. Welcome to the first lecture in knowledge discovery in databases. Today we will be talking about some organizational stuff. So I will introduce myself, I will introduce how we are working this semester, and we will get to know the very basics of KDD. Let's start with a prologue first. First, who am I? I'm Dominik Probst. I'm a research assistant at the Chair of Computer Science 6. I'm currently researching on data compression, so not on data science, but data compression, which is a related topic. I'm your lecturer for the semester. I'm actually giving this lecture for my third time solo and for my fifth time in total. So I have some experience with giving KDD. However, please bear with me. If there are small mistakes in there, then just inform me about the mistake. Mistakes are human, that might happen. One very important thing, I'm not a doctor, I'm not a professor. Please do not address me as doctor or professor. I'm obligated to always correct you if you do, and that's pretty tedious, so please just refer me as Mr. Probst, or I'm even fine with Dominik, but please do not use professor. That's not good for me because it takes some time. We also have 5 exercises this semester, and of course we have some tutors for this. These tutors have been part of KDD in the last summer semester. They have been studying KDD in the last summer semester. They passed the exam with great success, and now they are helping you doing the same, hopefully. So we have a good amount of different perspectives on KDD, which is always great. More on the exercises later on in the blog, but for now we will skip that. Okay, knowledge discovery in databases as a module, specifically knowledge discovery in databases with exercises, since we have 2.5 ECS lecture and 2.5 ECS as an exercise, is primarily targeted at data science, computer science, IIS, studies. Of course, there are some other study programs that also can take KDD. If your degree isn't written down here, then you might be able to take KDD, but we are not able to help you with doing that. So if you are studying any other degree program, we are fine if you take KDD. However, you always have to make sure that you can register for the exam, and that's something we can't do for you. So you have to make sure with the examination office of your study degree program whether it's possible to take KDD or not. And I will not be able to help you. We are a lot of people. Today, the lecture hall isn't that full. However, we have a live stream. I also made sure that works. And I'm pretty sure a lot of people are on there as well. So we have a lot of people. I can't help everybody doing these stuffs. So please make sure you are either studying any of these degree programs or you clarify with your examination office beforehand. For KDD, there are no prerequisites that are required. However, there are some useful things. For example, you should ideally have some experience with databases. Why? Because in the exercises you will be required to write SQL queries, and SQL queries are something that we don't teach in KDD. So you should have some experience in writing SQL, otherwise the exercises get a little bit harder. You can still do them, so it's totally fine. However, they get harder. Of course, since we are doing the exercises with Python and Python notebooks, experience with those two things are also good. However, we have some exercises introducing these things to you. So if you do not have any experience with Python and Jupyter Notebooks, that's not a problem. We will introduce them to you, however, in some fast manner. So we will not take a whole semester, of course, introducing Python and Jupyter Notebooks, but only one exercise. Specifically, the exercise next week. Basically, we have a big goal for the lecture, and that's to introduce you to the principles of data mining. So we would like you to learn how to work with data, how to gain insights from data, and how to gain knowledge from data mining, from data. So knowledge discovery in databases, basically. In the lecture, we have 8 major topics. We have the introduction, which is basically what is KDD at all. We have data, so how can data be structured? For example, we can have unstructured data, we can have structured data, we can have relational data and things like that. Then how to pre-process data. Before you're starting a data mining project, you should always start pre-processing the data. That's the next topic. Then we will have a small excursus to data warehousing, which is basically the databases part of KDD. So how is data stored? How can we access data? How can we store data? Prepare data for data mining. We will talk about frequent patterns. We will talk about classification. We will talk about clusters, clustering, and we will talk about outliers. Those are the 4 major applications we are doing on data. In the exercise, we will have an optional introduction into Python and Pandas next week. So if you do not have any experience with Python and Pandas, I would suggest to you to visit those exercises. If you are already experienced with Python and Pandas, there's no point in visiting next week's exercise because it's just a repetition. So the very basics of Python and Pandas. After that, I would always suggest to you to visit the exercise. So the topics on data analysis and data preprocessing, frequent patterns, classification, and clustering are highly relevant for the topic at all, in total, but also for the exam. We have a lot of questions that are based on the exercises in the exam, so you should visit them. We will also have a third major thing in this module, which are the submissions. We will have 3 submissions. These 3 submissions are about frequent patterns, classification, and clustering. The submissions are something where you can work in teams to really code some of the methods we are introducing in the lecture and the exercises. These submissions are not something you have to do, because we will not, it's not required to pass KDD. However, you will unlock access to a mock exam with passing these submissions, and that's highly recommended. And also we have experienced everybody who does do the submissions by themselves does significantly outperform the others in the exam. So it's basically more about the experience, but than just a tick. Okay, let's talk about exercises first. Exercise sessions are in presence, so we will not have any recordings or any live stream of the exercises. That's due to the fact that we are working together on exercise sheets in these exercises. So the tutors and you are trying to solve the exercises in place together to gain experience, for example, in Python, Jupyter, or doing data science tasks at hand, or also theoretical exercises. So there will be some exercises that are pretty close to the things you will do in the exam. For example, you will perform a priori by hand in the exercises, and there's a high chance that some part of that will be also part of the exam. So that's something you can do together in the exercises. And that's also great to ask in the exam. For the practical exercises, so where you are using Python and Jupyter notebooks to analyze data, of course you require some type of computer to do that. Since all the exercises are done in H4, which is our lecture hall right here, we do not have any computers in there. However, you are required to bring some kind of laptop, tablet, or things like that with you. I know that not everybody has access to a laptop. And of course, I know that you will not buy a laptop just for KDD. But then please make sure that you have any study buddy who's next to you who has access to a laptop so you can work together on these exercises. Because you will not gain any experience by just looking at the tutors and listening to their sample solutions. That's not how exercises work. For the exercises, we have also some preparation that is required. Of course, if we have an exercise, for example, on frequent patterns, you should always prepare the lecture on frequent patterns beforehand. Because here we are talking about the basics, and in the exercise we go into more depth in that. But also on all the exercise sheets there's a small preparation section. For example, for next week it is to install Jupyter notebooks and Python on your computer. That's something you should always do beforehand, because we do not have any time to do these preparation things in the exercise. The tasks themselves are tasks to be done in the exercise. So you do not have to prepare the exercises at home and then just talk about the solutions. You can do the exercises themselves in the exercise. There's enough time for that, but there's not enough time for the preparation phase. So please complete the preparation section beforehand. That's something that my tutors also asked me to emphasize in this lecture, so next week doesn't get messy, or at least not that messy. Why do we need exercises? I already teased that, but I can show you whatever. I can show you a little statistic based on the exam from the summer semester 24. In the summer semester 24, we had 3 big exercises or big tasks based on exercise tasks. All these exercises or tasks had a very, very low average score achieved. So in general, you need 50% of points to pass the exam, and the tasks that were nearly carbon copies of the exercises had average scores below 12%. So very, very low scores achieved in tasks which have been studied or exercised a lot in the sessions. Why was that the case? Well, we had only 5% of students visiting the exercises. And of course, if only 5% of students visit the exercises, then there's nothing to gain from the exercises. Why am I showing you the summer semester 2024? Well, because I've already shown this graph last year, and then more people showed up to the exercises, more people took part in the exercises, and more people passed the exam. We had very, very good results last summer semester. Because being part in the exercises and participating in the exercises helps you a lot with the exam. If you do not visit the exercises and do not take part in them, just visiting them is not enough, you have to participate in the exercises, then you will have significantly better results than if you wouldn't. I can't promise you that you will pass with a 1.0 if you just visit the exercise. Of course, that's not something I can promise to you, but I'm pretty sure if you participate in the exercises and participate in the lecture, then it's not a great struggle to get a good or very good grade in KDD. KDD is not a hard subject if you participate. But you have to participate. Okay, so reminder, exercises are very crucial for the exam. A lot of questions are based on the exercises, or at least have some parts in them that are done in the exercises. So please also go into the exercises. In fact, due to this semester's lecture being live streamed and recorded, I would even suggest it's more important to visit the exercises than the lecture, because the lecture you can always look up later, but the exercises are for something that is only done once, so beware. Next thing, the submissions. I already teased them as well. The submissions are programming tasks, 3 in total, where you are asked to implement some algorithms we are introducing here in the lecture, and also are doing theoretical tasks in the exercise. And to gain a deeper understanding of these algorithms, it's always great to implement them, because then you will gain insights on what parts did you really understand, what parts you didn't understand of these algorithms. These algorithms have to be implemented in Python and then be submitted into a GitHub Classroom. GitHub Classrooms are basically a tool provided by GitHub, so Microsoft, where you can get access to an individual repository where you can submit code as a team and get instant feedback on whether you pass some tests or do not pass some tests. So we have an automatic grading of these submissions, and you can always resubmit until the deadline is reached, until you get the amount of points you want to get. And basically, you are working in teams of up to 3 persons. There's no requirement that these 3 persons have to visit the same exercise session or be of the same nationality or whatever. You can mix up as you want. And then you are working together, committing together into a repository, and all the points are merged together for your team. So if your team reaches 70% of points, all 3 members receive 70% of points for that submission. At least as long as you are not copying other teams' solutions, but that's, of course, something you should always have in mind. Again, participating in or passing the submissions is not mandatory, so you do not need that for participating in the exam or passing KDD at all. However, you will unlock access to a mock exam. We do not have any past exams in KDD. We do not hand them out. In fact, we also search for them in the web if we see some old exams being published. We actively do legal actions against them. So we do not allow publishing old exams. However, the mock exam is something we do hand out, which is a tailored old exam, more fitting the new exam, where you can practice your skills before the exam. So it's great to have access to the mock exam. And I would really recommend you to participate. Are there any questions up to here? Maybe. Okay. Then we can get to the exam. The exam in KDD is, of course, a written exam. It will take 90 minutes, so you will have 90 minutes of time to pass the exam. They will have questions on lecture, exercise, and submission content. Submission content in asterisks because we only have submission content which is also covered by the lecture and exercise. So, of course, submission content is included, but it's also lecture and exercise content by definition. The language of the exam is, of course, English. You will be allowed to have a single-sided, thin A4 paper, handwritten, very important, no printing allowed, with you in the exam, where you can write down everything you want, as long as it fits on within a A4 page. If you have small handwriting, I'm pretty confident you can fit a lot of that onto this thin A4 sheet. We will collect these thin A4 sheets after the exam, so you gain some experience by writing within A4 sheets and just do not just use another person's thin A4 sheet. That's the reason for no printing as well. So you gain some knowledge by writing down stuff. There are no electronic devices allowed in the exam, including calculators. There will be calculations, but only simple calculations. So if you are at a university, you should be able to do these calculations in your head. However, I'm just informing you now, but calculators will not be allowed. I see you. Yeah?
For the cheat sheet, does it need to be written with a pen or like those, written with an iPad or something like that?
Okay. I repeat the question just for the live stream. You asked whether you can also use an iPad to use whatever digitizer to write down the cheat sheet. Since there's no printing allowed, and that would require printing, of course not, it isn't allowed. For the same reason as the other things are happening, we want to avoid that you are copying the homework of other students. If we would allow iPad stuff, which I would be totally fine with, in fact, but you can simply copy the cheat sheets of other persons by that. And I really would like everybody to do their own cheat sheets because it's a great learning experience writing down stuff. And most often by writing down stuff, you already learn these things, a little bit at least. So that's the thinking train behind that. Cheat sheet, no calculators. Very important next thing is that you have to register for the exam. If you are not registered for the exam, we cannot allow you to write the exam. This includes problems with study programs, as I already said beforehand, but it's also about people that just forgot to register. There's a registration period. Currently, it stays at May the 18th to June the 7th, where you can register on Campo for the exam, and only in that time frame you can register. You have to also register if you are in the second try or third try. There is no automatic registration anymore, so you always have to register yourself. If you are not registering within that period, you can write a mail to the examination office, and maybe they will allow it, but there's no guarantee that they will allow it. And sometimes they will say, go to the lecturer, and he registers you. I won't do that. We, as a chair of Computer Science 6, decided to never do any registrations for students because we had some problems in the past, and there's a strict line I got by my boss. I'm not allowed to register any students by hand anymore. So please work on that yourself. Put in a reminder into your calendar so you make sure you're registered for KDD. You can always unregister. So in fact, you can register for the exam, and I think until 3 work days before the exam really happens, you can unregister without any problems on Campo. So maybe just register and then, go step back if you do not want to take the exam anymore. But do not forget to take registration. Okay. Besides that, we can talk a little bit about the dates. In fact, you are already here on the lecture. Oh, sorry. Yeah.
Is the exam in the first or the second examination period?
I can promise that to you. However, currently it stays at the Monday, the second Monday of the first examination period. It's the current date we got by the examination office for the thing. You can visit our website, the CS6 website, and the specific date, the provisional date is written down there. I think it's the 20th of July, if I'm correct. I'm not 100% sure. Let me look that up. But it might change, and we can't do anything about that because it's just the examination office which decides that. 30th of July. 30 of July is the current date for the exam. But it might change, so take it with a grain of salt. Okay. Besides that, other dates, you're already in the lecture, you're already here, so you know that the lecture takes part here in H20 from 8:15 to 9:45 every Wednesday. And we also have a live stream and a recording available on Stardon. Small disclaimer, there might be technical problems at any point in the semester, so if that happens and you require these things, I can't do anything about that. And also the live stream is something that I might change at any point if I see that there are not enough people here in the lecture hall for me to gain some feedback, because I need feedback for my teaching. I need some faces that are confused if I talk bullshit. That helps me a lot. If I do not have anyone in front of me, it gets a lot harder for me. So the live stream is subject to change. If there are no people at all anymore in the lecture hall, it might change. As long as there are people here in the lecture hall, I'm fine with a live stream because I have some feedback and that's enough for me. The recordings are the same, of course. And just a small disclaimer as well for recordings. These recordings typically take some time after the lecture to be published. That's pretty normal. It might take some hours, it might take some days. I can't change anything about that. Just look them up regularly, and at some point they will be published. Besides the normal lecture, we will also have a small guest lecture this semester, and I'm pretty happy about that because this year I had the luck to gain a very good lecturer, specifically Daniel Kraus, who is co-founder and CIO of Flix. You might all know Flix. Flix is the company which operates FlixBus, FlixTrain in Germany, and in our countries also other trains and buses. So a very well-known and big company, and he will talk about data science in practice at Flix, which is a pretty interesting topic, I think. In fact, we didn't yet talk about the details on that. I have a meeting with him in late May. So if you have suggestions which things you might want to hear, I'm open to them, and I would like to pass them on. So if you have any things you would like to get to know about Flix, then just let me know and I pass them on. I can't promise that he will talk about them because they are, of course, company secrets he can't talk about. But besides that, he's a pretty chill guy. I know him from earlier in my life. So I'm pretty sure most things he will do if possible. Just write them down in the forum and I can pass them on. It's important to mention this guest lecture is not at the normal slot. It's on a Friday because Daniel is a pretty busy man. So it's a specific slot just for guest lecture. Of course, the guest lecture is not part of the exam. We will not ask anything about that in the exam. I would still recommend you to participate in the guest lecture because it's an interesting topic. You will gain insights on how data science is really carried out in the practice, which is nice to have. However, you are not required to be there because there's nothing to miss for the exam in these guest lectures. So that's important to mention. Currently, the slot stays at 10:15 to 11:45. However, it will probably only be a half an hour or 45 minutes guest lecture. So the slot will be smaller at the end, but that's something I will discuss with him at late May. So it will take some time to decrease the time frame. So currently just block the slot if you're interested in the guest lecture. And then the last thing are, of course, the exercises. These exercises start next week, so calendar week 17. We will have 5 exercises, and in fact, we will have 1 exercise per weekday. So we will have 1 Monday exercise, we will have 1 Tuesday exercise, we will have 1 Wednesday exercise, and so on. I do not think that any tutors are here. No, I don't think so. But all of these tutors are great. So you can visit all the exercises and will have gain great insight into KDD. So do not select specific exercises based on tutors, but select them based on your favorite time slots. In fact, the registration for the exercises will start after this lecture. Today at 10 a.m. we will open up the registrations for the exercises. There you can register on Staudann in the lecture course. There's a small piece in the exercise folder where you can register. There you can select preferred, okayish, and not possible slots for you. This phase will go on until Friday, and after Friday we will have an algorithm deciding on which exercise group is assigned to you specifically. So please use the time between today, 10 a.m. until Friday, I think 6 p.m., if I'm correct. Don't quote me on that. To register for the exercise groups, and then you will be assigned to a fitting exercise group for you. And nearly always you will get a preferred slot for your exercise, which is good. I'm expecting that the Wednesday exercise gets a little bit full due to the lecture being on Wednesdays, but the other exercise groups are also great. Then we also have, of course, a schedule. I already talked about the topics of the different branches of our module. So we have a lecture. Today we are talking, for example, about prologue and introduction. Next week we will talk about data and so on. While the exercise starts next week with introduction to Python and Pandas, and then we'll carry on with the first real exercise sheet, data analysis and data preprocessing for 3 weeks. There is some timing to that. This timing is subject to change. In fact, I will update the lecture slides every time the timing changes, so you can always look up the prologue to have some insight into the current schedule. Very important, we have some breaks in the exercises which are due to the fact that we have to talk about stuff in the lecture first, and then we can talk about them in the exercise. So there is a little free week in calendar week 21 where you just can chill, have some more time. And one very important thing as well is the submissions. The 3 submissions are towards the end of the semester. I know that this is not the preferred time frame for most of you because it's right before the exams. However, of course, the submissions are based on advanced algorithms, and advanced algorithms are things we can only do at the end of the semester. There's nothing we can change about that. They are just at the end of the semester. I will remind you about them, of course, once they get up. Don't be worried about that. You do not have to have any reminders on them in your calendar. That's just for your information right now. Okay, last things. I guess that everybody in here is already registered in Stardon. We have the Stardon course where I always upload the lecture slides, the exercise sheets, the submission sheets, and there's also the forum. The forum is the most important port of call for questions. I will not answer questions that are not including personal information via mail, because I always get the same questions 20 times, 30 times via mail. If these questions are asked in the forum, everybody can see my answers, and the questions only have to be asked one time. So please ask questions via the forum, otherwise you will just receive a note by me. I will not answer questions via mail. There's a small exception to that, of course. If you have questions that require you to hand out personal information about yourself, then it's okay to ask them via mail, because I wouldn't ask you to hand out your personal information via Stardon, of course. But there are only that little cases where this is feasible. So please use the forum as much as possible to ask questions. Also, there's the possibility of me getting sick or some other things changing. These things will be, if there are changes to KDD, I will write mails via Stardon, so it's important that you have access to that thing. You receive mails by me if I, for example, get ill. That's important as well. We have a second thing where we are publishing KDD slides and things like that. That's on GitHub. Basically, all our slides, all our exercise sheets, all our submission sheets are created with LaTeX. LaTeX is more or less programming word, I would say. We have a source control for our slides and our exercise sheets on GitHub, which is pretty great, because if you spot any mistakes, and there will always be mistakes on lecture slides, you can either inform me about that in the forum, or if you're confident enough with that, you can just correct them yourselves and do a pull request, which in the past a lot of students already did, and they have something great to show in their CV because they have a merged pull request in a huge lecture repository, which is always great to have. If you're confident enough with that, then I would be happy if you do a pull request. If you're not, it's totally fine just to inform me about a mistake, and I will correct it. One little other thing, we not only have the source code on GitHub, we also have some automatic building process on GitHub, and we have a GitHub page linked to that. So all lecture slides get published on a public website as well. So if you are at any point interested in upcoming lectures, which are not yet published on Stodon, you can always take a look at GitHub and see the upcoming lectures. They might change until we get there, but for this semester I do not have significant changes planned, so they are pretty much close to what you will see in the lecture at that point, which is pretty nice to have, I think. Okay, and that's all about the prologue. Do you have any questions on knowledge discovery in databases as a module at all? Are there any things that I forgot to mention? Are there any unclarities in here? I don't think so, okay. Then we can switch to the first real slide set, the introduction, where I will introduce you to the principles of knowledge discovery in databases. So what is knowledge discovery in databases? We will talk about why we need data mining or knowledge discovery in databases, what is data mining or knowledge discovery in databases. We will talk about a little multidimensional view of data mining, because we can talk about what data is available. We can talk about what patterns we are looking for, what technologies are we using, and what is the actual application we want to create with these insights. And we will talk about major challenges, and in every lecture, starting from now, I will always give you a little summary at the end, but that's nothing too special. Let's start with why we need data mining. Well, today we have a lot of data. In fact, in the last years, we got from terabytes to petabytes to zettabytes and beyond of data. Every website, every smartphone, every device you carry with you collects a lot of data, data points. Every industry has a lot of tools which are collecting data as well. Every energy plant collects data. And this collection of data is pretty much automatic. We are just gathering data. However, gathering data is nice, but without analyzing these data sets, we can't do anything with that. Those are just ones and zeros, in fact. We want to use this era of big data to gain some insights. Just as a visualization, I found that pretty nice. These are zettabytes on the y-axis. In 2010, there have been an estimated 2 zettabytes being collected per year. 2 years ago, there have been an estimated of 132 zettabytes per year being gained. So it's an exponential growth. Which leads to us being in a lake of data, a lot of data, we are drowning in data, we have an ocean of data, in fact, but we do not have any knowledge within these data sets if we are not looking in the correct way. And the basic idea behind data mining is that we can use this ocean of data to fish for knowledge. We can try to find knowledge within the ones and zeros. And basically, that's what data mining is about. There's a definition for data mining. Data mining is the extraction of interesting patterns from huge amounts of data. Interesting is defined as non-trivial, so it wouldn't be data mining if you just can take a look at a data set and see, yeah, there are a lot of females in there, just by looking at it in a second. That's very trivial. We want something that isn't possible to be seen within a split of a second. We want that to take some time, to be non-trivial. We want implicit data. We want previously unknown data. And of course, we want potentially useful data. And, well, patterns, not data, patterns. There is a lot of discussion whether data mining is the correct terminology for that. Because you are not mining data, you are mining knowledge within data. So that's a difference. But data mining is the most well-known terminology for that. Often, it's also called knowledge discovery in databases or knowledge mining in databases, which is in fact how we called our module. It can be also called knowledge extraction, data pattern analysis, data dredging, information harvesting, or for the IIS students in here, also business intelligence is a pretty well-known terminology. All these things might have slight differences in their definitions. However, they are basically the same thing. They have some small changes. For the sake of KDD, you can take them as somewhat of synonyms. I already teased that not everything is data mining. Because if you have trivial things, for example, that's not data mining at all. We would consider, for example, an analysis of customer behavior for advertising. That would be data mining. It's not trivial. I don't think your behavior is trivial in any case. It's not explicit. It's not known yet, and it's potentially useful. So all 4 points of our definition are fulfilled with such analysis. An analysis of payment histories for fraud detection is also non-trivial, it's implicit, it's previously unknown, and it's not only potentially useful, it's arguably very useful if you detect fraud. Or for COVID-19, for example, that's when I decided to take in this example, an analysis of infection behavior for better understanding of a pandemic is also non-trivial and very helpful. Not considered to be data mining are, for example, simple SQL searches in a database, searching females in a database, joining two databases, and that's something you only might understand if you already have some experience with SQL, but I'm joining two databases, basically merging them together. That's also not data mining. And also having some simple deductive clauses in your database, which are, for example, triggering any effects in your database. Those are not data mining as well, because they are too trivial to do. The next thing we have to talk about is not only what is the definition of data mining, but also how the process of data mining carries out. The process of data mining can carry out in different ways. It's basically the same between communities, but different communities do have other views on this. For example, in the database community, so my community, I'm at the chair of Computer Science 6, which is data management. That's our view. We have a very specific, typical view on the knowledge discovery or data mining pipeline at hand. First, we have data. We have data in a database or a data warehouse. We have data at a database. This database data then gets integrated into a data warehouse, which is more or less the integrated form of a database, or multiple databases, in fact. We will talk about that in lecture 4, data warehousing. Then, from the data warehouse, we select specific task-relevant data, because there might be data sets in there which we do not need for our specific task. Why should we use these data points if we do not need them? Once we have selected the data, we can then apply data mining to that and end up with some kind of visualization. Visualization in this case also includes textual visualization, I have to say. So in most cases, you will end up with pretty graphs, but in some cases, you might also have some textual output, which is also visualization for the sake. And by this visualization, you can look at the results and gain knowledge, have knowledge discovery, have insights you do not have before. This view is not the view of the business community. Again, IIS students in here. The business community has more of a pyramid view of data mining. Oh, sorry, wrong direction. In the business community, it's more or less about stacking things on each other. Here too, we start with sources of data, which might be a database, which might be also just papers or files in your cabinet. These sources of data are then preprocessed and integrated in a data warehouse, for example. So that's the same thing basically as in the database community. Then we are exploring these data sets. We are taking a look at the basic statistics of this data set. We are trying to gain some basic insights into the data set. Based on that, then we start with data mining. We try to discover information in them. We are using more advanced techniques on these data sets. Then we go to the presentation, which is of course also important because especially in the business community, you have some people that work with the data and some people that are deciding based on these data sets. So we need visualization or presentation as well. And then we end up with a decision. So in fact, they are not that different at all, but they are slightly other views on the same thing. In fact, there are a lot of communities that have slightly different views on knowledge discovery or the data mining. We have also a standard which is shared between the communities, which is, oh, sorry, I'm one step too fast. We also have the ML community, which is about having a data input, doing data pre-processing, then doing data mining, then doing post-processing, which is basically the visualization step from beforehand, and then we end up with knowledge, which is also pretty the same. So a little bit different again, but pretty much the same in here. And between the communities, we also have a shared standard process, the CRISP DM, the cross-industry standard process for data mining, short CRISP DM. This standard process consists out of 6 steps, which should be carried out during data mining or knowledge discovery. We start by gaining some insight on our business case. So we try to find which objectives do we want to fulfill. We try to assess the situation. So which data do we have at hand? Or not which data, which targets do we have at hand? What are our goals to fulfill? And we try to find a specific plan to carry out our project. Once we succeeded with that, we can go to the next step, which is data understanding, where we collect the data we have at hand. We collect the initial data, we try to describe the data, try to gain very basic insights again into data. For example, count how many data points we have, or doing a simple min-max analysis on these data sets. And we also, and that's very important, try to verify the data quality, because data is often dirty. That's something we'll discuss next week. If we have dirty data, we have to do things with this data in the next step, the data preparation step, where we try to select the data, where we try to clean dirty data, where we try to construct by integrating data together, new data points or cleaner data points. And where we also integrate and format data, because we might have different sources of data which are in different formats. For example, we might have a database carrying out mails as mail, and we have a second database which carries out mails as simply M, which would be different formats, and then we have to bring them to the same format to be able to work with them in a good manner. Just after doing that, we can go to the modeling step. The modeling step is where we really carry out any data mining methods or algorithms. For example, we will take a look at a priori in our lecture. A priori would be part of step 4, where we apply a model to this thing. Or if you are into neural networks are not part of KDD. Quick disclaimer, but neural networks would be, training a neural network would be part of step 4 as well. So also modeling, carrying out, training a model on our data, building a model, assessing a model, and so on. After training the model, we of course have to evaluate. Are our results what we expected? Did we find the patterns we have been looking for? Did we succeed in our data mining goals? by doing that. If we succeeded, we can carry on to step 6. If we didn't, we might have to go back to the drawing board and start again with more insights, of course. If we succeed, we can of course deploy, and then we can use the pattern discovery methods we had at hand to deploy, for example, a monitoring and maintenance phase, or to produce a final report, depending on whether we have an ongoing analysis or we have a one-time analysis. That's basically the thing. This process is nice because it's shared across industries. So we have one basis which is shared between the ML community, the database community, the business community, and many more, which is nice to have. Okay. Any questions so far? No. Okay. Then let's get to the next topic. The multidimensional view of data mining, and what I'm trying to carry out with that is, of course, different questions we have in data mining. For example, we have the question, what data is available? We can have a lot of different data points, which is something we will take a closer look at in next week. But everybody in here should know different data points. We have, of course, databases, relational databases, which is the arguably most structured form. But we can also have a handwritten DIN A4 cheat sheet with a lot of information on that. That's also a data point. We can have pictures. Those are also data points. We can have recorded smells, maybe. Those are also data points. Data can come in a lot of different forms. And our data project, or data mining project, depends a lot on what data do we have available. Because we can have the best method for mining data in a relational database. If we just have handwritten DIN A4 sheets at hand, it will not work. At least not by default, with a lot of pre-processing maybe. Then we have to look for patterns. And we have to decide what patterns are we looking for. Are we looking for frequent patterns? Then we can use a priori maybe. Or are we looking for similar data? Then classification or clustering might be better. Which is basically also about the next point. What technologies are used? So a priori is a technology. DBScan, a clustering algorithm, is also a technology. What resources do we have at hand? Do we have just a smartphone at hand? Do we have a supercomputer at hand? That, changes a lot of things. We can do other things with these things. You can't train ChatGPT on a smartphone. You can train it on a lot of servers. So you have different possibilities with that. And of course, what's your actual target application? What's your goal in the data mining project? Let's start with what data is available. I already said there is a lot of different data formats. In this case, on the slide, I do have some other examples. We can have relational databases, we can have data warehouses, we can have transactional databases. Those are the most basic and most structured forms of data, but we can also have data streams and sensor data. We can have NoSQL databases. We can have text databases, we can have the World Wide Web, we can have that many things as a source of data. The important thing is that any kind of data can be meaningful. And if it's meaningful for my target, then I can use it. What does meaningful mean? Well, a cheat sheet for KDD is useful for a KDD exam. It's not useful to do an analysis of customer behavior at Amazon. So the context decides a lot. There can be data that is meaningful for the one application. It might be not useful for the other application. And that's something that is important to remember. Data might be useful, might be not useful. But we can use every type of data with different efforts to gain insights. The next thing is, what patterns are we looking for? Because searching for right patterns is pretty important. It tells me a lot about what functions can I use. I already said a priori, I already said dbScan. dbScan is great in looking for clusters in data. A priori isn't. A priori is a freaking pattern algorithm. Those terms are nothing you have to know right now. You will know at the end of the semester. But the data mining function depends a lot, or decides a lot on what patterns can we discover in our case. Also, the data set has to include these patterns, otherwise we can't be able to discover them. If the pattern isn't contained in our data set, we can't use it. Something we might see in the exercises at some point. Something that's also very important is just because we are finding or discovering patterns, they might not automatically be useful. So there's also the possibility that we find a pattern which isn't useful. A great example for that is an example I will come up with later on in the semester as well, but I just use right now. Do you know about the difference between correlation and causation? So there might be two things that correlate with each other. So for example, it might happen that the temperature outside correlates with how many people are in this room, whatever. These things might grow together, might fall together, whatever. There's no guarantee that these are causations of each other. So maybe the temperature leads to less people being here, then it would be a very useful pattern to know. Because then we can, for example, install ventilation in here, so it gets less hot in here. That would be causation. If there is no causation, then it's not a useful pattern for us, because we can't gain any insights, when it might be just by chance that these two things correlate. And that's something that is also very important to have in mind. Just because you find something, it's not always interesting. We will discover a lot of data mining functions in the semester. We will, for example, talk about data transformations in the first 3 lectures. We will talk about frequent pattern analysis, so a priori, for example, in lecture 6, about classification in lecture 7, clustering in lecture 8, and outline analysis in lecture 9. So we will talk about a lot of different functions once the time is come. That's what KDD is about. There are, of course, a lot more methods we can cover in here. The most important one maybe is neural networks due to ChatGPT and other LLMs. I think these neural networks are the hottest shit in town, but there are other lectures that are focusing on them, for example, deep learning by Mr. Meyer or by Professor Meyer. We will not focus on them, we just will mention them at some point, but that's not our focus, where you need a specific lecture tailored to neural networks because it's a huge topic. Yeah. Okay, then what technologies are used? In basic, knowledge discovery or data mining is always a confluence of multiple disciplines. We have, for example, the database technology, which is most often used for data mining. But without the statistics community, a database wouldn't be enough. We need some basic statistics. We also need some algorithms for data mining to work out. We need some applications to work out. We can use machine learning in here. In fact, we are using a lot of machine learning in KDD. Depending on the data set, we might need natural language processing to do things. That's something we will not use in here, but which is nice to have. We need some visualization techniques, some pattern recognition techniques. Depending on what method you are using, you might also use high performance computing, so supercomputers more or less. Data mining is basically a confluence of multiple disciplines, and depending on the technologies you have at hand, you can do different stuff. Again, a neural network, a bigger neural network will not be trained on a small smartphone. That's not happening. And even a lot of our traditional machine learning methods we are talking about in this lecture are not possible to be done maybe on, what's a good example, on a Game Boy Color, whatever, on a very old piece of equipment. That's not work. Basically, each discipline contributes something to data mining and therefore contributes to the technology which is available in here. Algorithms, of course, provide the basic algorithms. Machine learning, for example, the specialized algorithms. High performance computing, if you are in need of bigger or more power to handle the large data sets. Database technologies, we are needing for very efficient storage. You might see in the semester that a database is very good in handling huge amounts of data very performantly without getting struggle that fast, which is nice, and so on. And depending on what technology we have at hand, we can, of course, provide or use other patterns, search for other patterns, take a look at other data sets, and, of course, be faster with that. Okay, and the last thing, what's the actual target application? I already teased that as well. That's basically depending on what data target application we have at hand, we might need different data points. But wherever there's data at hand and we are in need of knowledge, there are data mining applications that can help gaining that knowledge from this data, if the data contains the patterns we need. We have a lot of data mining applications in our daily lives as well. In fact, there are many more than that. We have, for example, business intelligence, which is used to enhance business processes. We have web search engines. Those are data mining as well. We are looking at a huge pool of data, a lot of websites. And we are looking for the ones that are fitting best to your search query, which is data mining. It's non-trivial, it's previously unknown, and so on. We have fraud detection, that's already mentioned. We also have predictive maintenance, which is important to keep industries running. Though there are a lot of things. Also, we have a lot of data mining projects at FAU. I've looked that up, I think 2 semesters ago. If you're looking for data mining in the current research information system, which is a website provided by FAU, and where you can look up different projects at FAU, and you're just looking for the term data mining, you will find above 100 different projects on data mining currently running. I've written down a lot of them, some of them in here, but there are a lot of more than them. It's a little bit outdated. Ms. Escoffier, for example, just left the FAU, but there are a lot of different projects in there. If you're interested in that, just take a look at the current research information system and you will find a lot of data mining projects. Maybe even for a master project or master thesis, if you're interested in that, it might be nice to look that up, to contact the correct persons. Yeah. So we have different perspectives on data mining, and we will discuss most of them during the period of our semester. We will get into details on many of them. This is just a little overview over the different topics. We have to give an overview before we can dive deeper into the different topics. And that's what today is about. The same thing has to be said about major challenges in data mining. It's also an overview. We can't get into details on that, but we will get into details on that during the semester. In data mining, we can, of course, have a lot of different challenges which have to be solved, and either we can already give you a solution for that during the semester, or these solutions are actively worked on in the research. For example, the mining methodology. We can, of course, or we have to find different kinds of knowledge, different kinds of patterns, and we need different methods to do that. LLMs are just one of the newest, latest solutions to find new patterns. We can always come up with new methods to find new patterns, kinds of patterns. And to be honest, I do not think that LLMs are the last step in there. There will be many more to come to find new patterns. We have to mine knowledge in multidimensional spaces. So we can have different dimensions in a space, which is something we will talk about later in the semester. But the more dimensions we have, the harder it gets to mine these data sets, because it gets more resource intensive to do that. We have to somehow manage the differences between our disciplines. Maybe the high performance community, high performance computing community has other terminology than the database community. Those terminologies have to be merged, have to be somewhat be understood if we are working between disciplines. We have to handle noise incompleteness of data. Those are things that are solved pretty much, but we still have to talk about them. We have to talk about pattern or constraint mining. We have to talk about interactive mining, incorporation of background knowledge. So maybe there's an expert in your domain which can help you with their knowledge, and so on. The scalability of things is very important. The diversity of data types is very important. And of course, and that's especially true, I think, for neural networks, but also for other methods, we do change things in our lives by doing data mining. We also have to think about the ethics of data mining, because we might change a lot. And with LLMs, I think everybody agrees on that there has to be some ethical threshold on doing this stuff. But it's true for traditional machine learning as well. Okay, but that's just a little overview over KDD as a whole. Of course, there are a lot of things we can talk about in more detail, and we will talk about them in more detail. Today, we just learned about what is data mining in general, how the data mining process carries out in general. We will carry out a data mining process by ourselves in the exercises. We talked about the important aspects to think about, and we quickly talked about challenges. Those things have just been a little overview. Next week, we will get into the first real topic, data. So we will talk about how data can be structured, and we will basically talk about this point, what data do we have at hand and how to handle these kinds of data. Okay, so far so good. Do you have any more questions? Doesn't seem like it. Then, have a nice day, have a nice week. See you again next Wednesday. And one small thing, please never use vStores because they are secured by alarm. And if you use vStores, please always use these little buttons because otherwise the doors get jammed and that's also not good.